Welcome to another example question about constant acceleration in one dimension. I'm Mr. John from explainingmaths.com. It says a lift rises vertically from rest, that's important, accelerating at a constant rate, so we're talking about constant acceleration, until it reaches a speed of 1.6 meters per second after 8 seconds. Okay, let's start by writing down all the things that we know before I even read the exact question. So we know the initial velocity, u, is 0, because it starts from rest. Now that's a piece of information some of us tend to forget to spot. Its final velocity is 1.6, so v equals 1.6, and then it's after 8 seconds. There we go. What is the first question? Find the acceleration of the lift. So we're looking for A. What is the acceleration? Now writing this little diagram is going to help me to pick the equation of motion that will find my answer. So I'm going to pick, and those equations need to be in your head. I'm going to pick V, the velocity, the final velocity, equals u plus at, because those are the variables I know. I know that 1.6 equals 0 plus a times, t, 8. So 1.6 divided by 8, so the acceleration is going to be 0.2 meters per second square. There we go. Alright, 0.2. Moving on to question B, it says the lift then continues to accelerate for a further 2 seconds. Find the distance that the lift has now risen. So as you can imagine, that lift is going up, and then they're asking for what is the displacement, how far, what is the distance that the lift went up. So I'm going to use the formula now. Let me just try to squeeze it in over here. I'm going to use the formula that S says that the displacement equals ut plus half at squared. There we go. And u is 0, so ut is going to be 0, plus a half times its acceleration, which is 0.2, times for a further 2 seconds. So in total, he is moving to plus 8, so for 10 seconds in total, so 10 squared, which is 100, times a half, which is 50, times 0.2, so that's going to be 10 meters in total. Okay. Moving on to the last part, it says the lift then shows down, and I'm pretty sure that they mean slows down, so that's not shows but slows down at a constant rate, so a constant deceleration, and stops after a further 5 seconds. So after those 10 seconds in total, 8 and 2 seconds, 10 seconds in total, it starts slowing down for a further 5 seconds. Find the total distance traveled by the lift. So I'm going to find now the distance in those last 5 seconds, and then I'll add it to 10 to find the total distance of the journey. Okay, so for those last 5 seconds, I'm going to make a new diagram, because my initial speed at the start of those 5 seconds is 2 meters per second. Do you understand why? Because it started from 0, from rest. What does it say that? From rest. Constant acceleration, from 0.2 meters per second squared, for in total of 10 seconds then. So after those 10 seconds, 10 times 0.2, u will be 2. So its speed, its velocity at that particular moment is 2. So u will be 2, and it's slowing down for a further 5 seconds until it stops. So its initial velocity v is going to equal 0. There we go. And that is going to take him 5 seconds. The question is, what is the displacement? What is s? I'm going to use this equation of motion now, where s, displacement, is a half times u plus v times t. And if you fill in the blanks, so you have a half, u is 2, v is 0, so 2 times, or was that 5? So a half times 2 is 1, times 5, it is 5. So in those final 5 seconds, the lift will travel another 5 meters. So what is the total distance traveled by the lift? It's going to be 10 for the first 10 seconds, plus 5 meters in those last 5 seconds. So in total, it will have traveled 15 meters. I hope that was useful. I'm Mr. John from explainingmaths.com. Like and share if it was useful, and check my website for all the other free resources. Take care.